Now let us see the third point, variation in gravitational acceleration with the latitude and rotation of the earth. What is latitude? Latitude is an angle made by a radius vector of any point from center of the earth with the equatorial plane. Now the value of latitude ranges from 0 degree at equator and 90 degree at the poles. Now this is just, we'll try to understand the meaning of the latitude and how exactly it differing from equator to earth. So this is earth rotating from west to east, right, and equator, this is an equatorial line, and then this, the pole is, we know this is north pole and south pole. Now this is a plane and a line which is making an angle with this equatorial plane. This angle is called, now in this angle you have to imagine in 3 dimension. This angle is called as latitude. Now when this line is at equator, this equatorial line, this angle is 0 degree Celsius, and when it at pole it is 90 degrees. So latitude at equator is 0 and at pole it is 90 degree, right? So this is what. Now consider a point, any point which is, now earth is, as earth is rotating, you can see earth is rotating from east to west, and consider any point on the surface of the earth, like imagine any building. So that building also rotates with the same speed as the speed of the earth. Now see, this is what, so this is what the, any point is on the surface of the earth, it also moves with the same direction. Now what I will do is, I'll just take two vectors. So this is radius vector. So there are two planes, you can see from this figure. The equatorial plane is this, and there will another circle which you can say, you can imagine as a plane for the motion of the point which is moving with same as velocity of earth, right? So this animation can be imagined as a figure. So let us imagine this same animation with the help of some figure, right? So the earth is rotating with an angular speed omega, equator you can see, center of the earth you can see, and the radius of earth is denoted by r. Now this, let us, the point P, exactly same point P is there, drawn on the surface of the earth. So line joining OP is also shown. Now the surface, the circle which is the, in which the point is, the point of the any object is moving from on, which is located at point P, the radius of that small, that is a small circle as compared to equatorial, you can see that. So that radius is equal to r, right? So now we'll consider this triangle only, this part, we'll consider this part for further calculations to find out the variation in g, right, due to latitude, change in latitude. Let's see. Earth rotates about its polar axis from west to east with uniform angular velocity omega. Consider a point P, any point P of mass m on the surface of the earth, which we have shown, making an angle theta as shown in figure. Let r be the radius of circle and capital R we know is the radius of earth. So from figure PO dash, the same triangle I have taken it, from PO dash is equal to r. So this is PO dash is equal to r, and then OPO dash is equal to theta. So this angle and this thing, so O and OP is equal to capital R, that is the radius of the earth. Now from figure what I can do is I can find out the cos theta. Cos theta is equal to adjacent upon hypotenuse. So adjacent upon hypotenuse is, so this is PO dash, so this is adjacent upon hypotenuse, so r upon r. So cos theta is equal to r upon r. So from this, if I calculate the value of r, that will be r is equal to r cos theta. So this is the first equation. Now the centripetal acceleration along OP dash, centripetal acceleration along OP dash. Now what is the OP? So that centripetal acceleration, centripetal acceleration along OP, so that this equal to OP is equal to a r omega square. So that centripetal acceleration is equal to a r omega. So we have seen this formula when we have seen the centripetal force and centripetal acceleration while we in the part of circular motion. So a is equal to r omega square. So where a is acceleration, centripetal acceleration, r is the radius, and then omega is the angular velocity. So if you substitute this a in equation number 1, so a is equal to r into omega square cos theta. So this is very clear. Now let's see the radial component of, now what is this radial component? The radial component is given by a cos theta. Now from where this radial component came, or a vertical component. Now imagine the same figure, O dash P O, and then this acceleration, we know this OP is the radial acceleration, centripetal acceleration. This is the acceleration along the radius of the, so this is earth radius. So earth radius, and the centripetal acceleration is along the radius, so it is along the a. So along OP is acceleration. So we can, now I can show OP as an acceleration, but if OP is a vector, I can resolve this vector in two components. One component is vertical component, another component is horizontal component. So two components, one is this and other one is this. So two components. So this is horizontal component. This one component is called as horizontal component. This component is called as vertical component. This component will also be known as the radial component. So just see, this is a sin theta. So just remember this. Now horizontal component will always be, if this is the situation, this is the case, horizontal component will always be taken as a sin theta and vertical component will always be taken as a cos theta. So this is the resolution of vector A. We have seen this while we have studied the chapter of resolution of vectors. So vector in vector chapter. So vertical component is, or radial component is a cos theta. So that is what is the radial component, a cos theta. So if I have substitute this value of A from this equation, so A, if I substitute this A here, so that is equal to A R is equal to R omega square. So this is the value of A which I have substituted from previous equation. So R omega square cos theta into this cos theta. So that makes me AR is equal to R omega square cos square theta. Now this is the radial component of acceleration. What this is acceleration. Now I have to, but what I'm trying to find out is the force, right? And that is what I need to find out. So I need to find out G. So effective force on attraction, force of attraction at point P will be the combination of this. Is the result of this, right? This, what is the result? So mg dash, so at point P will be mg weight minus the component, the radial component. So mg dash is equal to mg minus m r omega square cos square theta, just multiplying by m. So if I remove this, if I take m constant and if I cancel it, I'll get a g dash is equal to g r omega square cos square theta. This is the actually gravitational acceleration due to change in the latitude, right? Due to change in the angle theta. Now as theta increases, cos theta decreases. As theta, you can see from this, as we know this, cos theta can have value from 0 to 1, that's it, right? 0 to 1 and minus, so minus 1 to plus 1, that is what is the cos theta's value. So as theta increases, cos theta decreases, therefore g dash will increase as we move away from the equator toward the pole. What does it mean? The physical interpretation of this is that at the pole, when theta is equal to 90 degree, you can see it, if you substitute theta is equal to 90 degree, you can see that will be cos 90 is equal to 0. So g dash is equal to g. In that case, g dash, value of g dash is equal to maximum, that is 9.8 at poles. So what does it mean? I need to be very clear. We must understand that gravitational acceleration at equator is minimum, while the gravitational acceleration at pole is maximum. Because at equator also, you can, in this equation you can put equator, at equator you can have the value theta is equal to 0. So if you put that, the entire will go 0. So g minus 0 is, that is what, right? So cos theta, so that you can understand from this figure, right? So now that is what we have seen, all 3 points of the variation in g due to height, variation of g due to depth, and then variation in g due to gravitational acceleration due to the latitude and rotation of the earth, right? So 3 mathematical formula also came, and physical interpretation also we have seen it very clearly. Now see, what is the effect of this g value, change in g value, on the shape of the earth? Now actual shape of the earth is an ellipse, the earth is ellipsoid, right? This is what we look, it is a sphere, but it is not a sphere. The gravitational acceleration at poles is higher, right? So due to this higher gravitational acceleration, what happens, there is a pull from the two poles toward the center of the earth, and this pull, because of this pull, the shape of the earth is now an ellipsoid. Actual shape of the earth looks like an ellipsoid, where the length of equator is more, radius along the equator is more than the polar radius. So equatorial radius is more than the polar radius. So equatorial radius, if it measures 6378 kilometers, 6378 kilometers is the equatorial radius. Gravitational acceleration, we know it is minimum at equator, so its value is 9.7804 meter per second square. And if you weigh somebody, if you try to find out weight of some person or any object or any body, it will measure minimum at equator, it will measure minimum at equator. So you must understand. Similarly, at poles, polar radius, you can see it is 6356, it is less by 20 kilometer than the equatorial radius. So polar radius is lesser than the equatorial radius. Similarly, gravitational acceleration is maximum 9.8322. The maximum gravitational acceleration is maximum. Why it is maximum? We have seen the formula also, and we have seen the reasons also. G is equal to 9.8322 at polar, and the weight will be the maximum. As G is maximum, mg will be maximum. So the person who is standing on equator will weigh more if he or she or the object is taken to the polar, any pole, north pole or south pole. So this is what there are three points which are very important or to be focused in this. One is the shape of the earth, what is the shape of the earth, and then what will happen to the weight or gravitational acceleration or radius of the earth at equator as compared to pole. So this is what is the point. Let's move to the next point. Now see, with the help of the formula, mathematicians and scientists have calculated what is the value of G at different angles, different latitude. At 0 degree we know it is minimum 9.7, and at 90 degree you can say it is maximum. In between it is increasing from 0 to 90 degree, 9.78 to 9.83. Fine. So this is what, these are the values which are there. Now let us move to the next point, gravitational potential energy, and it's an important point, right? Now we know work done, the formula for work done, we know that is force into displacement, and symbol is capital U. We are using capital U as a symbol of gravitational work done. We will be using it, the formula, the symbol for work done. For example, W is equal to, or U is equal to force into displacement. So let displacement is equal to x and force is equal to F. So F into x. Now a small work done, if I am taking it a small work done, what will happen is du is equal to fx dx. This f into dx, sorry, this is f into dx. So small displacement into force will give me the small work done. Now you know that increase in the potential energy of the system is work done against the conservative force acting on the object. What does it mean? It means we know it, like what is the definition of energy? Its capacity to do work. Like, so work done is equal to whatever work done is there, it is equal to the capacity, its capacity. Like capacity means potential energy. So it's basically energy and work done are same. Increase in the potential energy means potential energy is equal to work done. That is what it's telling. But increase, why I am telling, because we are taking something body from surface to the height or something, but we are doing against gravitation. That is what increase or decrease. We have to measure in terms of increase and decrease when we are talking about gravitational potential energy. So basically what you can see, part of it, potential energy is equal to work done, that we know. And if you don't know, you must remember it. Potential energy is equal to work done, right? Potential energy is equal to work done. Now for gravitation, we have to see in terms of either increase or decrease, and against the conservative force, that is gravitational force. So work done against gravitational force is equal to du is equal to f into dr. So force into displacement, but here dr is the distance which is from center of the earth to the object, height of the object. Why minus? It is against, the negative sign indicates work is done against the gravitational force towards the center of the earth, and we are taking the body or an object away from the surface of the earth. So it is opposite direction. Consider an object which is moved from position Ri to Rf. Now we are moving, the initial position of the object is Ri, initial Ri, and the final position is Rf. Now total work done can be obtained by integration. We know that this is integration we have seen in the physical mathematical formulas. So if we integrate that equation, delta U is equal to initial Ri, limit Ri to Rf minus f dr, right? Minus dr. Why minus? Because again the work done is in. So f is equal to, now we know that f is equal to minus g mm upon. Why you have taken this? Again the gravitational force is against the, so that again we have to take it in negative direction. So delta U is equal to minus Ri to Rf with minus if you substitute value of f is equal to minus g mm upon r square into dr. So minus minus will get cancelled. G gravitational constant, m mass of earth is constant, m mass of small m is mass of object, will be constant for that particular situation. So g m m are constant, so I can take it outside of the integration, and the integration will be a limit from Ri to Rf dr upon r square. So 1 upon r square, you know, the integration of 1 upon r square is minus 1 upon r. The integration of 1 upon r square is 1 upon r. So if I substitute this, so this is the integration of r square, 1 upon r square is minus 1 upon r, and the limits will be Ri to Rf. Limits will be Ri to Rf, right? Now this, what is the limit? This is lower limit, this is upper limit. When we solve this, we know we have to substitute the upper limits first. So the upper limit has been substituted. So instead of in place of r, I have substituted Rf. This is what is meaning of definite integral, right? So value substitution, limit value substitution for integration. So first value, the upper limit will be substituted, minus 1 as it is. So r will be replaced as Rf. Now we know that minus sign will always be there when you put two when you substitute the limit. So minus sign, in between we always put a minus sign, minus r. Now we will put the value of lower limit to in place of this. So first you have to submit the upper limit minus lower limit, upper limit minus lower limit. So upper limit minus 1 upon Rf minus 1 upon Ri. So if you simplify this, delta U is equal to GMM. So this minus minus will become plus, this minus and this minus will become plus. So I'll take this Ri at first. So in this I'll take it here. So 1 upon Ri minus 1 upon this Rf, minus sign will come, this minus sign will come here, right. So further simplification, now we know that this initial Ri is the radius of the earth, and Rf will be considered as the position of the any object which is above the surface of the. So we can take r is radius is very much greater than the r. So 1 upon r you can take it as in 0. So delta U become, if you substitute this 1 upon r, first 1 upon r is equal to 0. So the equation will become, so this will become 0. So delta U is equal to minus gm upon r. This is basically the expression for gravitational potential energy. This is an expression for gravitation. Just remember, this is an important formula. Delta U is equal to minus gmm upon r. This gives the expression for gravitational potential energy. Fine. So let's move to the next point. Now the relation between U and we know that the potential, the formula for potential energy up till now we were knowing in terms of kinetic energy and potential energy. The potential energy we termed as mgs. The potential energy is due to the height gained by an object. So mgh. So now what is the relation between the expression which we have just now found and mgh? So let us find out the relation between these two. So gravitational potential energy at surface of the earth is given by, you know, any surface is, let us call it as an U1. At the surface. So U1 is equal to minus gm upon r. So now, and gravitational potential energy at height h. So what will change? Only the r will change. So it is equal to minus gmm upon r plus h. So what is the difference now? Because we have to find out the difference. Difference is moving, if we move from if you take it from surface to above some height h. So it means that we have to take the difference. So increase in potential energy will be delta is equal to U2 minus U1. If I substitute these two values, so that's first value minus gm upon r plus h will be substituted, and minus gm upon r. So this minus sign, so this is first U2 and this is U1, right. So two substitutions are there. Now if I simplify further, this will go minus minus will become, see, this minus minus will become plus. So this sign, this will be taken, then plus will be taken first. So gmm upon r will be taken as a plus quantity minus gm upon r plus h. Now if I take gmm common, so it will remain 1 upon r minus 1 upon r plus h. If I simplify this with cross multiplication, what will happen? So delta is equal to gmm. So r plus h, this 1 into r plus h is r plus h minus r. So r plus h minus r upon multiplication of these two. So r into r plus h, right. So this r will be, now plus r minus r will cancel. So what delta U will remain? Delta U is equal to gmm. So h upon r into r plus h. Further simplification, delta U is equal to gmm upon h upon r plus h. So now just multiply this r and substitute. We know this g, small g, gravitational acceleration is given by gm upon r square. So if I can substitute, because here I have the value of gm, right. I have the value of gm, so I can substitute the value of gm with this, from this formula is equal to gr square. So if I substitute gr square, so delta U is equal to gr square. So this gr square into small m into h upon r square into rh, right. So this gr square only substituted, rest there, and this r square I have multiplied, r into r is r square and then rh. Okay, simplify further. So if I take now this is what I need to take out, right. M, G and H, 3 I have taken as a common part, and then this r square inside, and then r square plus rh, right. Now let us divide with r square. So numerator and denominator. So at numerator there will be 1. So r square is 1, r square upon r square is equal to 1, and rh upon r square, so is equal to h upon r, right. This is upon r square. Just imagine, so upon r square, so 1 r will get cancelled, so it will be h upon r. So delta is equal to mgh 1 plus h upon r. But again, h upon r is you can approximately take 0 because h is very small as compared to r. So you can take it 0. So if you substitute this h upon r is equal to 0, so delta u is equal to mgh 1 upon 1 plus 0. So 1 plus 0 is 1 upon 1 is 1. So this entire bracket, this entire value of this bracket is will be equal to 1. So delta u is equal to mgh. This is what is the formula. It means that these both potential energy formula are same, like delta u change in potential energy is equal to mgh. If it is gravitational potential energy, it is minus gmm upon r. This is the the formula for gravitational potential energy, mgh also and minus gm. So in terms of gravitational acceleration and height, and in terms of mass and the distance, right? So you must remember these formulae. Now let us move further. The concept of potential, which is last point for this session. The concept of potential we know as gravitational potential. This is an important formula. Gravitational potential is energy upon mass. Any potential is equal to energy upon mass. Potential always potential energy equal to energy upon mass. So gravitational potential energy equal to gravitational potential equal to gravitational potential energy upon mass. So let us substitute this. V is gravitational potential. The symbol is V. Gravitational potential energy is u. We have just calculated u. So V is equal to u upon m. If you substitute this, so what is change in difference is V2 minus V1. This is change in gravitational potential is equal to u2 minus u1 upon m will remain same. So delta u upon m. So dw upon m. So this is, think on this. It means concept of potential is related to change in work done per unit mass or change in potential energy per unit mass. Just imagine some concepts like where you are taking some body from surface of the earth to up a certain height h. What exactly is happening? Where is the change in potential energy, and what is the work done? What is happening work done, and why we are calling this as an work done against the gravity? Fine. Thank you very much. We have seen all points for this session 1 or the part 1 from 1 to last point, that is concept of potential, introduction to concept of potential. If you have any problem, any questions, you can write mail to mail, or you can call me. That number is also given from the first slide. So my email ID is professor.rizwan@gmail.com, right? If you have any questions, you can call me, or you can send me in WhatsApp on my WhatsApp number also. Thank you very much. We'll see you in the next portion.